back up. No, not presenting this. I'll go back to presenting. There we go. People and that, and back here. Okay, so to recap what we're looking at, our new example, how much energy is involved in 3.5 grams of water going from liquid to gas, 20 degrees Celsius to 135 degrees Celsius. We have to do this in 3 steps. The first step, where it's a liquid, raising in temperature from 20 to 100. Then we have to calculate the energy change to go from liquid to gas. Then we need a third calculation from 100 to 135, because that's when it's in the gaseous phase, and our specific heat constant is different when it's a liquid or a gas. So here's what that would look like. The first Q is equal to the mass, 8.5 grams of water, times the specific heat where it's a liquid, which is 1 calorie per gram Celsius, times the change in temperature. 100 minus 20 is 80 degrees Celsius. And on our calculator, we get 682 sig figs. Calories, that's because grams cancel and degrees Celsius cancel. Then our change from liquid to gas, we have 8.5 grams. We're going to change grams to moles using the molar mass of water, which is 18.02 grams per 1 mole. Then we're going to change from moles to kilocalories. Kilocalories, liquid to gas, is a positive 9.72 kcals. And from that, we get 4.58 kilocalories. And then step 3, our Q for going from 100 to 135, the mass is still 8.5 grams. The specific heat for water when it's a gas is 0.481 calories per gram Celsius. And then 135 minus 100 is a positive 35 degrees Celsius. And we get, with 2 sig figs, 140 calories. It's actually 143.0975, but we're going to take it down to 2 sig figs. So this is the mistake I was seeing, and I apologize. It means I probably didn't explain it well, that we needed to have separate Q calculations if water was changing temperature in a different phase, whether it was a liquid, so that's anywhere between 0 and 100, whether it's a gas above 100, or if it's a solid below 0. So we have 2 Qs, and we're going to add all 3 of these together. So we have 4.58 kcals. I'm going to change 680 to kcals. That's 0.680 kcals. And then 0.140 kcals. Add those up. Oops, sorry, this should be 2 sig figs as well. So that should be 4.6. 2 sig figs. We get 5.42. Looking for our dad. Our answer is 5.4 kcals. Okay, does anyone have any questions on how I solved for that? Anything I can clarify? Okay, so while you're doing that, I am going to stop recording.